All right, let's look at these polynomial inequalities. In this, whenever you're solving a polynomial inequality, the first thing that you want to do is get one side of your inequality equal to 0. So I'm going to do that by adding the 5x and subtracting the 3 over to the other side. So I have 2x squared plus 5x minus 3 less than 0. Now what I'm saying in this statement here is that I want this polynomial to be less than 0. In other words, I want to find out when this polynomial is negative. Because if we're less than 0, then that means we're negative. So I have a quadratic here. I need to factor this. I'm going to multiply my first and last terms. And if I do that, I get negative 6x squared. Factors of negative 6x are 2x and 3x, 1x and 6x. Since my 6x squared is negative, I need to subtract to get my middle term, which is 5. So I'm going to plus 1 and minus 6x. So now I'm ready to rewrite my quadratic as 2x squared plus 1x minus 6x minus 3. And now I'm ready to factor by grouping. I'm going to group these first two terms together. Out of those two terms, I can factor in x, and I'm left with 2x plus 1. Out of my last two terms, I can factor a negative 3. And if I factor out a negative 3 from 6x, I have 2x. That minus, since I'm factoring out a negative, it becomes plus. And then if I factored out a 3 from 3, I'm left with 1. My parentheses came out the same, which is good. 2x plus 1 times x minus 3. And we still want this to be less than 0. So now I have it in factored form, and my next step is to identify my zeros. Where is this polynomial or these factors going to be equal to 0? For my first factor, that 0 would be negative 1/2. And for the second factor, for x minus 3, the 0 would be positive 3. I started out with a quadratic. I should have expected 2 zeros, and that's what I have. And so now we're ready to do the number line. So I'm going to draw this number line, negative infinity to positive infinity. And I'm going to label my zeros on here. Negative 1/2 is the smallest 0, and then 3. So now what I'm going to do is pick a number in each interval and test it to see whether or not that interval is greater than 0 or positive, or less than 0 or negative. Because remember, what I'm looking for is when this polynomial is negative. That's going to be my answer. So in this first interval, from negative infinity to negative 1/2, I'm going to pick a number in that interval, like negative 5. And what I'm doing here, I'm going to write down my work, but you can do this in your mind. I'm going to substitute the negative 5 into my factored form. So I'm going to say 2 times negative 5 plus 1. And if I were to work that out, I would end up with a negative number. And then I'm going to substitute negative 5 into my other factor, and again I would end up with a negative number. If I multiply a negative times a negative, I end up with a positive. And so that means for that entire interval, this inequality, this polynomial I mean, is going to be positive. So now let's look at our next interval. Between negative 1/2 and 3, I could choose 0. And so I'm going to substitute 0 into my factors. 2 times 0 plus 1, that's going to come out to be a positive answer. And 0 minus 3, that would come out to be a negative answer. And if I multiply a positive times a negative, I get a negative. In my final interval from 3 to infinity, I'm going to pick the number 5. So 2 times 5 plus 1, that would turn out to be a positive answer. And 5 minus 3 would also be positive. And a positive times a positive is a positive. So that interval is positive. Now again, remember that I was looking for when the polynomial is negative. That's my answer. And that's happening right here on this interval. So the solution to my polynomial is the interval -1/2 to 3. And since it's just less than and not or equal to, I'm going to use parentheses for that interval, and that would be our final answer. Let's look at this next inequality. 25 is greater than, greater than x squared. So first thing I need to do here is get one side equal to 0. So I'm going to do that by subtracting the x squared. So I get 25 minus x squared greater than or equal to 0. My next step is to factor. And what I have here is a difference of two squares. 25 is a square number, x squared is squared. And so to factor a difference of two squares, I should have 5 and 5 and x, plus and minus. So 5 plus x and 5 minus x greater than or equal to 0. Now my zeros from these factors, from the first factor, I get a 0 of -5, because 5 plus -5 would be 0. And in the second factor, my 0 would be +5. So now we're ready to go to our number line. So I'm going to draw a number line from -infinity to infinity. I'm going to mark off -5 and 5. And now we are going to choose our test values and see which intervals are positive and negative. Now before we do that though, let's go back to our inequality right here. 25 minus x squared greater than or equal to 0. So what I'm interested in is when the polynomial is greater than 0 or when the polynomial is positive. Those are the ones that I'm looking for. So let's pick a number between -infinity and -5, such as -10. If I substitute -10 into my first factor, I get a negative answer. And if I put -10 into my second factor, I'm going to get a positive number. And so negative times positive would be negative. In my next interval between -5 and 5, I'm going to choose 0. And if I substitute in 0 into my first factor, I get a positive answer. And if I substitute 0 into my second factor, I also get a positive answer. And positive times positive would be a positive. And finally, in my last interval, between 5 and infinity, I'm going to pick the number 10. And if I substitute in 10 in my first factor, I get a positive answer. If I substitute 10 into my second factor, I get a negative number. And positive times negative is negative. So this time I was looking for where the intervals are, which intervals are positive. And so that's going to be this interval here. And so my answer is going to be the interval from -5 to 5. And since my inequality includes an equals to, we're going to use brackets. So this is our final answer. Let's look at the next example. Again, I want to start out by getting 0 on one side of the inequality. So I'm going to add 10x squared. 10x squared. Still have -11x minus 6 greater than 0. So now I'm ready to factor. I'm going to multiply my first and last terms, and I get -60x squared. So I'm going to list the factors of 60, and I'm looking for two numbers that are going to subtract to give me 11. Since my 60 is negative, I need to subtract my numbers to get that middle term. So let's see, factors of 60, 6 and 10, those aren't going to work. 5 and 12 doesn't work. How about 4 and 15? 4 times 15 is 60. Those are going to subtract to give me 11. I need a +4 and a -15. So I'm ready to rewrite my quadratic. 10x squared. Instead of -11, I'm going to put +4x minus 15x. And then we have -6 at the end. And I'm ready to factor by grouping. I'm going to group these first two together and factor out the greatest common factor, which would be 2x. If I factor out a 2x from 10x squared, I'm left with 5x. And if I factor out a 2x from 4x, I'm left with 2. In my second group, I'm going to keep that minus sign and factor out a 3. Factoring out a 3 from 15x leaves 5x, and factoring out a 3 from 6 leaves me 2. And the sign is changing to positive because I factored out a negative. My two parentheses are the same, which is good. So my factored form would be 5x plus 2 times 2x minus 3. And we still want this to be greater than 0. So now that I have it in factored form, I need to identify my zeros. For the first factor, for 5x plus 2, the 0 would be negative 2/5. And for the second factor, the 0 would be positive 3/2. So now I'm ready to make my number line. Negative infinity to infinity, and negative 2/5 would be the lower number, positive 3/2 would be the higher number. And so let's start testing intervals. In my first interval, I'm going to choose negative 5. And if I substitute in 5 times negative 5 plus 2, that's going to come out to be something negative. And then 2 times negative 5 minus 3, that would also be something negative. And so a negative times a negative is a positive. If I pick a number in between negative 2/5 and positive 3/2, I'm going to choose 0. So 5 times 0 plus 2, that will be positive. And 2 times 0 minus 3, that will come out to be negative. And a positive times a negative would give me a negative. Finally, in my last interval, I'll choose positive 5. So if I do 5 times 5 plus 2, that's going to give me a positive number. And if I do 2 times 5 minus 3, that also gives me a positive number. And positive times positive is positive. Now I failed to identify what we were looking for here. Let's go back to our inequality right here at this step. You can see that we want our polynomial to be greater than 0. So if I'm greater than 0, that means that the positive intervals, those are going to be my answer. And so this time I have 2 positive intervals, and so my answer is going to be the interval negative infinity to negative 2/5, parentheses always on negative infinity, but also a parentheses here because my inequality is just a greater than. And then we're also going to have the interval 3/2 to infinity. And that would be the final answer to our inequality. Let's look at number 4. This time I have a cubic polynomial. I still need to get one side equal to 0, so I'm going to subtract x cubed over to the left side, and I'm also going to reorder my terms here so that they are in the right order, and less than or equal to 0. So before we go on, let's think about this. I want the polynomial to be less than or equal to 0, which means I'm looking for negative intervals this time. If my polynomial is less than 0, that means it's negative. Now often when you have a cubic, we would need to do some synthetic division to find one 0. But we don't have to do that here because every term has an x. And so I'm going to factor out an x. And in fact, I'm going to factor out a negative x. And if I do that, I'm left with x squared minus 3x minus 28. So factoring out that negative causes the signs to change, but it also leaves me with a positive x squared term. And so now I need to factor this quadratic, the x squared minus 3x minus 28. I'm going to start out by multiplying my first and last terms, which gives me negative 28x squared. I need to find factors of 28 that subtract to give me 3. And you're probably thinking 4x and 7x first. We need a positive 4x and a negative 7x. So now I'm ready to rewrite my quadratic. I'm going to keep the negative x out there in front, and then I'm going to write x squared plus 4x minus 7x minus 28. And now I'm ready to factor by grouping. If I group together the first two terms, the only common factor is x. And if I factor out an x, I'm left with x plus 4. Out of the last two terms, the common factor would be negative 7 or minus 7. And if I factor out minus 7, I'm left with x plus 4. And then if I rewrite that, both of my parentheses are x plus 4. So I'm going to have x plus 4 times x minus 7. Those are my three factors. It's a cubic. I should have been expecting 3 factors, which also means I need 3 zeros. Now whenever I have an x by itself, like this first factor, that's going to give me a 0 for 0. And for my next factor, the 0 would be negative 4. And for the final factor, the 0 would be positive 7. So now let's go to a number line. Negative infinity, positive infinity. My lowest number is negative 4, and then 0, and then 7. So let's substitute in numbers from each interval. In the first interval, I'm going to choose negative 5. If I substitute that in, I would have negative negative 5, which would be positive, times negative 5 plus 4, which is negative, and negative 5 minus 7, which is also negative. So positive, negative, negative means that interval would be positive. In the next interval, I'm going to choose negative 2. So I would have negative negative 2, which would be positive. Negative 2 plus 4 will also be positive. And negative 2 minus 7 will be negative. So positive, positive, negative, that gives me a negative. In my next interval, I will choose positive 1, which gives me minus 1, which will be negative, times 1 plus 4, which would be positive, and 1 minus 7 will be negative. And a negative times a negative is a positive. And finally, in my last interval, I'll choose 10. So negative 10 is, of course, negative. And 10 plus 4 would be positive. 10 minus 7 is also positive. And so a negative times a positive is a negative. Now again, let's remember what we were looking for. We were looking for when the polynomial is less than 0 or negative. So these are my answers here. I do have an or equal to this time, so I'm going to use brackets. Negative 4 to 0 is a negative interval, and 7 to infinity. And that's our final answer. Let's look at one more problem together. In this one, I'm going to subtract 4. So I have x cubed plus 3x squared minus 4 greater than 0. I want this to be greater than 0, which means I'm looking for when my polynomial is positive. And I need to factor. Now in this case, I need to do some synthetic division to find one of my zeros before I can factor. I need to think about my factors would need to be factors of 4, which is my constant term. My initial coefficient, my leading coefficient, is just 1. So really my only choices are the factors of 4, 1, 2, and 4. So let's try 2. I'm going to list my coefficients, 1x cubed 3x squared. Notice there's no x term, so I need to put a 0 and then a negative 4. I'm going to bring down the 1, and 1 times 2 is 2. 3 plus 2 is 5. 5 times 2 is 10. And this is obviously not going to work. So let's move on to another choice. Let's try negative 2. 1, 3, 0, and negative 4. I'm going to bring down the 1. 1 times negative 2 is negative 2. 3 plus negative 2 is 1. 1 times negative 2 is negative 2. 0 plus negative 2 is negative 2. And negative 2 times negative 2 is positive 4. Negative 4 plus 4 is 0. All right, so I found a 0. Negative 2 is going to be one of my zeros. And let's just start a list of zeros. So negative 2 is one of them. And now my coefficients, or my numbers here, 1, 1, and negative 2, are going to be coefficients on a quadratic, x squared plus x minus 2. And so I'm going to multiply the first and last term. I get negative 2x squared. Factors of negative 2x are 1x and 2x. I need a positive x in the middle, so I'm going to choose negative 1 and positive 2. I'm going to rewrite my quadratic as x squared minus 1x plus 2x minus 2. And I'm ready to factor by grouping. Out of the first group, I can factor in x, and I'm left with x minus 1. Out of the second group, I can factor a 2, and again, I'm left with x minus 1. And so my factored form here is x minus 1 times x plus 2. And so the zeros that I get from that, from x minus 1, that gives me a 0 of positive 1. From x minus 2, again, I get negative 2, which is already on my list. So if we were graphing, this would be like a double root. But we're not graphing. We're just looking for positive and negative intervals. So I'm going to go ahead and do my number line, negative infinity to infinity. And normally we would have 3 zeros for a cubic. But this time we only have 2 because one of them is a double 0. So let's see what happens here. I'm going to pick a number in this first interval from negative infinity to negative 2. Let's pick negative 5. Now here's one thing we need to do. We have this factored form right here, x minus 1 times x plus 2. But that's only 2 of my factors. Remember that negative 2 is a double factor, and so we could write it as x plus 2 squared, or you could list them separately, x minus 1 times x plus 2 times x plus 2. Either way is okay. The nice thing about this first way, if I have a factor and it's being squared, then that means that no matter what I substitute in for x in that factor, once I square it, this is going to become positive. And so if I think about that, that makes my substitutions a lot easier because now I only have to substitute into x minus 1 because I know x plus 2 squared is always going to be positive. All right, so in my first interval, I'm going to choose negative 5. If I substitute negative 5 into x minus 1, I get a negative answer. And if I substitute negative 5 into x plus 2 squared, that's always going to be positive. So a negative times a positive would be negative. In my next interval between negative 2 and 1, I'm going to choose 0. If I substitute 0 into x minus 1, that of course would be negative. And my other factor squared is always positive. So a negative times a positive gives me a negative again. Notice there's no sign change. And that's what happens when you have a double root. Because remember, if we were graphing, the graph would come down and touch the axis and go back up or down, but it wouldn't cross. No crossing the axis on the graph, no sign change on the inequality. And then let's pick a number in our final interval, 1 to infinity. I'll just choose the number 5. If I plug in 5 in my first factor, it's positive. The second factor is squared, so it's always positive. and so I get positive for that interval. Now remember, in my original inequality, I wanted the polynomial to be greater than 0 or positive, and so this positive interval is going to be my answer, 1 to infinity. That would be the solution to the inequality.